Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number. This is the 15th part of the series of CSIR NET Physics 2021 paper solution. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started. Okay, so question number first of the day. Okay, so this is the question. I'm going to start. I'm solving part C questions, and this is the last lecture of the series of 2021 paper solution. Okay, I'm going to start. So question first is tomorrow onward I'm going to solve 2022, 2023, June and December, 3 papers I'm going to solve. Okay, so I will take 3 lectures from tomorrow onward, in which I'm going to solve 2022 paper and 2 papers of 2023, that is June 23 paper and December 2023 paper. Okay, okay, so let's get started. So question is, potassium chloride. It's a good question guys. Potassium chloride, potassium chloride potassium chloride forms an FCC lattice in which K and Cl occupy alternating sites the density of KCl, potassium chloride. Okay, the density of KCl is 1.98 gram centimeter cube, and the atomic weights and the atomic weights and the atomic weights of K and Cl are 39.1 and 35.5 respectively. respectively. The angles of incidence, the angles the angles of incidence, angles of incidence angles of incidence in degrees, for which for which for which Bragg Bragg peaks Bragg peaks Bragg peaks will appear when X-ray of wavelength X-ray of wavelength of wavelength X-ray of wavelength 0.4 nanometer 0.4 nanometer is shown on a KCl. Shown is the third form of sign, okay? Shown on the KCl, shown on a KCl crystal R. KCl crystal R. Okay, so options are: option A is 18.5, 39.4 and 72.2. These are in degrees, okay? And option B is 19.5. It's a good question, guys. 19.5 and 41.9. Okay, and option C is 12.5, comma 25.7 and 25.7 and 60. And option D is 13.5, 13.5, 27.8, 44.5 and 69. Okay, 69.0. So these are the options, guys. Okay, meanwhile, just let me check whether I'm audible or not. After that, I'll proceed further. For which Bragg peaks so I'll proceed further. Bragg peaks, okay. Okay, first I'll explain the question and after that I'll solve it. It's a good question, guys. So question is potassium chloride form an FCC lattice, okay. So KCl form an FCC lattice, okay, in which, so this KCl is forms an FCC lattice, okay, in which K and Cl occupy alternating sites. Okay, so they occupy alternating sites. The density of KCl is given, guys. This is the density, 1.98 gram per centimeter cube, and the atomic weights of K and Cl are also given, that is 39.1 and 35.5 respectively. The angles of incidence, okay, in degrees you need to find out the angles of incidence for which Bragg peaks will appear when X-ray of wavelength 0.4 nanometer is shown on a KCl crystal R. Okay, so when this X-ray is shown is a third form of shine. Okay, so that this X-ray is reflected on this crystal. Okay, so we need to find out angle of incidence for which Bragg's angle peaks will appear. Okay, and these are the options given. Okay, so let's solve it. Okay, guys. So we have a formula, guys. That is, we have this formula. I have already explained in my this in my lecture in condensed matter physics. Okay, so this A cube, that is lattice parameter, that A cube equal to n effective into molar mass upon Avogadro number Na into density of the crystal. Okay, and we can see this KCl is FCC structure. Okay, KCl has FCC structure which is given in the question. Okay, and density is also given, that is 1.98, and atomic weights, that is molar mass, is given, that is 39.1 and 35.5 for K and Cl respectively. Okay, angles of incidence for which Bragg's angle will appear when X-ray of wavelength 4 nanometer is shown on KCl crystal. Okay, okay, so this is the one. Now from here, A cube. So so now we have this crystal that KCl, right? So N effective, it's the FCC structure, right? Given in question, FCC. So it means N effective is, for FCC, we know N effective is 4, right? For FCC, N effective is 4, right? So this is going to be 4 into molar mass, that is 39.1 for K, plus 4 into, or we can write directly this one, sum of molar mass, that is 4 into 39.1 plus 35.5 upon NA Avogadro number, right? And this value we know, that is 6.023 into 10 to the power 23, and density we have been given, that is 1.98. Okay, so we'll solve it, and this value is going to be, you can use calculator for this. So this is going to be 2.5 into 10 to the power minus 22. This is the A cube, that, right? So from here, value of A is going to be this. We can write 2. This we can multiply by 100 and divide by 100. So this is going to be 10 to the power minus 24, right? So from here, value of, this is A cube, right? From here, value of A is going to be A cube, and now value of A is going to be, value of A is going to be 6.3 into 10 to the power minus 8 centimeter. Okay, this is centimeter cube. Okay, so or we can write 6.3 angstrom. Okay. Now we know the Bragg's law, right? Bragg's law we know for X-ray reflection or X-ray diffraction. Both things are same. So for that we know the X-ray, this Bragg's law. So Bragg's law is we know that is 2d sin theta equal to n lambda. 2d sin theta equal to n lambda, right? Because we have to find angles of incidence, right? This one. And n we can take 1. Okay, so this is going to be 2d sin theta is going to be equal to lambda. And lambda value we know that is given, right? That is this one. 0.4 nanometer means 0.4 into 10 to the power 9 meter, 10 to the power minus 9 meter, right? And since we know this d value is for this crystal, this FCC crystal, d value is going to be a upon root h square plus k square plus l square, right? These are Miller indices. It's going to be h square plus k square plus l square, right? This value d we know, so we can write 2 into a upon root h square plus k square plus l square, right? And into sin theta equal to n lambda is this is 0.4 nanometer means 0.4 into 10 to the power minus 9 meter, right? This is the one. Or we can write in angles this one, sin theta lambda, right? This one. Okay. Or we can write this is 4.4 nanometer means 4 angstrom, right? 4 angstrom. 0.4 nanometer means 4 angstrom. Okay. So and the value of A is going to be 2 into 6.3. This is angstrom. Okay. So upon root and this one h square plus k square plus l square, h square plus k square plus l square equal to 4, right? Now for FCC lattice we know that, right? For FCC, so there is a rule which I have, a selection rule which I have already mentioned in my lecture in condensed matter physics, that this one. So for Bragg's peaks will appear at the angle of incidence for which the Bragg's peaks will appear when X-ray of the wavelength 0.4 nanometer is shown on PCl crystal, right? So for X-ray diffraction, if you talk about if you talk about simple cubic, then in that case all values of HKL are acceptable, right? If you talk about that BCC, then all values that this for BCC it is all values of all odd values of HKL, right? And even values of HKL provided their sum must be divided by 4, means HK plus L divided by 4, right? For if we talk about for FCC lattice, for X-ray diffraction to happen for FCC lattice, I'll write it. Okay, for FCC lattice, for X-ray diffraction or reflection or reflection, same thing, reflection for FCC crystal. You can check my previous my lectures of condensed matter physics, that is completed. I've completed that detailed course of condensed matter physics in 22 lectures. You can watch that. That is available in the playlist. Okay, so for X-ray diffraction or reflection, for FCC crystal, number one, that's all odd or all even values of HEL. These are Miller indices, right? So here we can take simple values, right, for making our calculation easy. So we can take for 200, right? This is for all for FCC crystal, for X-ray diffraction, right? Uh, or reflection for FCC crystal, all odd or all even values of HKL. So I'm taking this two all even values, right? And I have taken 200 for easy calculation. So if I take this value, then we can put this value in equation 1. This equation, I can say this is equation 1. Okay? So I can put it. So this is going to be uh, 2 into 6.3 upon root 2 to the 4 h square plus this value, right? This one, h square plus k square plus l square. These are HKL value. So this is going to be 4 plus 0 plus 0 going to be 4, and this is sine theta, right? This one, this is sine theta. So from here we can find. So from here, value of sine theta is going to be if we calculate it, simple calculation, right? We can take this is going to be 2, right? So this is going to be 2. Root of 4 is 2 to the 8, right? So 8 upon 2 into 6.3. Okay, so this value is going to be 6.63. Okay, so that implies theta value is going to be sine inverse 6.63. Okay, and this value is going to be 39.4 degree, right? So we can check the options, which option is matching, right? So here you can see option A is matching, guys, because there is 39.4. In other options you cannot see any value of you cannot see 39.4. So this is the correct option. So other angles are these angles, right? So that depends on HKL values, right? So I have taken this value, that all even values, right? That is 200. That value I have taken, and I've got the answer, right? So 39.4 degree is the answer. So option A is the correct option, guys. So these are the angle of incidence. I hope, guys, you have understood it. Next question I'm going to solve. Question number 2. Okay. Okay. So any means, right? Okay. So you are asking me, I'm going to college BTech, sir. How can I crack CSR net by third year, sir? Is it possible? Can I do it? Sir, should I go for MTech? I'm confused. Okay, so as of now, I would suggest you just focus on your BTech course. Okay, and meanwhile you can give exam in your that exam for CSIR net. Prepare with your BTech, but make sure that don't compromise with your percentage in BTech. Okay, and if you, if you, I'm sure you will qualify. You will be able to qualify the exam. Okay, and if you qualify the exam, that CSIR net exam, so you have lots of opportunity. You can easily get admission in MTech if you qualify the net, right? And if you get a good rank, if you qualify JRF, then you can go for PhD. And also you can apply for GATE, because if you qualify the GATE, and you can easily get admission in MTech. So what I would like to suggest you, just focus on your BTech, right? And try to score well in BTech. Meanwhile, you give exam. Okay. Okay. Syllabus is same, and sir, I have a lot of confusion how to prepare. Okay. So if syllabus is same, what I would like to suggest you, yeah. So prepare for it, and but make sure that you are not compromising with your BTech score. Okay, because it is also important, because if you get a good score in BTech, means good CGPA, right? So then it will be easy for you to get admission. Yeah. So what I would like to suggest you, as of now, focus on your BTech. Meanwhile, give the exam and try to crack the net, right? If you qualify the net and if you qualify the JRF, then that it would be good. So that after that you have lots of opportunity. But don't compromise with your score in BTech, because once you complete the BTech, you can easily prepare for net easily, right? Or you can go for MTech, or you can give exam that you can give this one, that GATE exam, and you can easily get admission in MTech. Okay. So as of now, I would suggest you prepare. If as you told me, the syllabus is same, so prepare for it and give the exam. But make sure that you are not compromising with your BTech score. Okay. So next question I'm going to solve. I hope you have understood NEET, right? Okay. Okay. You're welcome. Okay. Next question we are going to solve. Next question is, okay. You're welcome. Okay. Next question. Next question is, it's also a good question, and this question is from condensed matter physics. This question is also from condensed matter physics. The question is, lead is lead is superconducting. Lead is superconducting below 7 K. Okay. So lead is superconductor below 7 K, 7 Kelvin, that is temperature, and has a critical magnetic field, as a critical magnetic field, critical magnetic field, field 800 into 10 to the power minus 4 Tesla, close to 0 Kelvin at 2 Kelvin, the critical current at 2 Kelvin, the critical current that flows through a long flows through a long lead wire of radius 5 mm, 5 millimeter, okay, is closest to. Okay, so options are 1760 ampere. Option B is 1670 ampere. Okay, and this is 1950. Option C is 950 ampere, and option B is 1840 ampere. Okay, so this is the question. I will explain the question first, and after that I will solve it. So question is, lead is superconducting below 7 Kelvin, okay, and has a critical magnetic field that is 800 into 10 to the power minus 4 Tesla, close to 0 Kelvin. Okay, so it at almost 0 Kelvin, the critical magnetic field is given. Okay, at 2 Kelvin, at temperature of 2 Kelvin, the critical current that flows through a long lead wire of radius 5 mm is closest to. So we need to find out critical current. Okay, this is 5 marks question, guys, and these are part C questions. Okay, so okay, so it's a formula based question, very simple question, guys. Okay, so there's a formula. I hope you know it. This is the formula is this one. SCT, that is critical magnetic field at temperature T Kelvin, is SC, that is critical temperature at 0 Kelvin, into 1 minus T upon Tc whole square. Okay, this is a formula, guys, and this one where Tc is so we have been Tc is critical temperature. Okay, Tc is critical temperature, SCT is temperature at this T Kelvin, and SC0, that is the temperature at 0 Kelvin. So since we have been given Tc, critical temperature is given. This is lead is superconducting below 7 Kelvin, means this is a critical temperature, right? Above this 7 Kelvin, it is normal conductor, right? So the critical temperature is given, that is 7 Kelvin. So we have been given Tc, that is 7 Kelvin. Okay, and also we have been given SC0, that is critical temperature at 0 Kelvin. This one has a critical magnetic field this at 0 Kelvin, right? So this is critical, it's critical magnetic field at 0 Kelvin, right? So this is this one, 800 into 10 to the power minus 4, 800 into 10 to the power minus 4 Tesla. Okay, so this is SC0 which is given. Now, now what I'm going to do is I'm going to find the critical magnetic field at temperature this 2 Kelvin. Okay, at 2 Kelvin the critical, we need to find out at 2 Kelvin the critical current that flows through a long lead wire of radius 5 mm is closest to. First I will find the critical magnetic field at temperature 2 Kelvin, and after that I will find this critical current. Okay, so SCP at 2 Kelvin is going to be, this value is 800 into 10 to the power minus 4 into 1 minus T is given, right, 2 Kelvin, and Tc is 7, this whole square. Okay, so we'll solve it. This is SCP. SCP is going to be SCP is going to be this one. So we solve it. So this is going to be 800 into 10 to the power minus 4, and this is going to be 1 minus 2 to the 4, 7 7 that is 49, right? And so SCP is value is going to be SCP. It's a formula based question. This is going to be 800 into 10 to the power minus 4. This is 49 minus 4 upon 49, right? This is 45 minus 49. 45 minus 49. Okay, so this is the critical temperature at 2 Kelvin, okay? Or I can write this critical temperature at 2 Kelvin. Okay, so now, but we have to find critical current, right? So there is a formula, guys, formula for critical current. These are important formula, guys, you need to note down. Okay. Okay. So critical current. Critical current flowing through that lead wire of radius 5 millimeter, right? So this critical current formula is, you need to note down that IC is going to be equal to 2 pi r, r is the radius of the wire, into HC, that critical magnetic field at 2 Kelvin, this is the temperature, upon mu 0, permeability, okay, magnetic permeability. This formula you need to note down, this one. So simple, now we just have to put the value, okay. So IC is going to be this is 2 pi r, so 2 pi r is given, that is 5 millimeter, means 5 into 10 to the power minus 3 meter, right? And critical magnetic field, we have been given this. So this is 800 into 10 to the power minus 4 into 45 upon 49 upon this one. Mu 0 value we know, right? Because there is a formula. I hope you know it, this one. Mu 0 upon 4 pi, that value is equal to 10 to the power minus 7, we know. From here, value of mu 0 is going to be 4 pi into 10 to the power minus 7. Right? We'll put this value. This is going to be 4 pi into 10 to the power minus 7. Pi will get cancelled. This simple calculation. If we calculate it, we are going to get this value. This value is going to be, simple calculation, you can calculate it. This is 18 137 ampere. So this is the answer, guys. A very simple question, and this is 5 marks question, part C question of 2021 paper. Okay, so it's a formula based question. So very simple question, right? So this is the critical magnetic field at any temperature is equal to critical magnetic field at 0 Kelvin into 1 minus T upon Tc whole square, right? And where Tc is critical temperature. Okay, so we just have to put the value, and we've got critical magnetic field at 2 Kelvin temperature, right? And now critical current, there is a formula, that is IC equal to 2 pi R SC upon mu 0, right? At SC at 2 Kelvin. We have just put the values and we've got the answer, right? So this is the current, that is critical current that flows through this lead wire, okay, at temperature 2. So this is the answer. So which option is matching, guys? Let me check. So option which one is which option is matching? 1837. 1837. 18, I think option D will be correct option. Let me check. Yes, option D. So this is the closest value, right? It is also, this is given, right? That the critical current that flows through a long lead wire of radius 5 mm is closest to. So this is 1840. So this is the answer, guys. This is the answer, and this is the closest value. I hope you have understood it. Okay, so next question I'm going to solve. The next question is question 3rd. This is also formula based question. So also, guys, just I wanted to tell you that I have solved complete paper of 2019, both June and December. I have solved 2020 paper that was in 12 lectures. Okay, so you can check my playlist. So you will get 2019 solutions of that June and December, and also I have solved 2020 paper, complete paper in 13 lectures, and this is also going to be completed today in 15 lectures. And tomorrow onward, I'm going to solve 2022 paper of CSIR Net Physical Science and 2023's June and December papers. So 3 lectures I'm going to take tomorrow onward. Okay, so I will solve 3 papers. Okay, so the question number 3rd is the Q value of the alpha decay of thorium 32, that's 232 thorium. Okay, so Q value of alpha decay of thorium 232 thorium to the ground state of of 228 radium in 4082. This is not in, this is misprint. Okay, so this is 4082 kilovolt electron volt keV. The maximum possible maximum possible kinetic energy of the alpha particle is closest to. Options are option A, this is 4082 kilo electron volt keV. Option B is 4050 kilo electron volt. Option C is 435 kilo electron volt, and option D is 4012 kilo electron volt. Okay, so this is the question. Okay. So question is, I'm going to explain the question first. Okay. Question is, the Q value of the alpha decay of 232 thorium to ground state of the radium, at 228 radium, is 4082 kilo electron volt. The maximum possible kinetic energy of the alpha particle is closest to. Okay, so the Q value of the alpha decay of thorium. So thorium, in thorium, alpha particle gets decayed. Okay, so and after that, because alpha particle gets decayed from thorium and it goes to ground state of radium, so thorium becomes radium, right, after alpha decay from it. Okay, and the Q value is given for this reaction. The Q value is given, that is 4082 kilo electron volt. Okay, the maximum possible kinetic energy of alpha particle is closest to. Okay, so we need to find out maximum possible kinetic energy. So what happened is, we have given the Q value for the reaction is the thorium. From thorium, alpha particle gets decayed, right, and then thorium gets decayed, that alpha particle gets decayed and becomes the radium, right, which is stable element, right, the radium, and the Q value for this reaction is given, that is 4082 kilo electron volt. The maximum possible kinetic energy of alpha particle is closest. Okay, so very simple. So we need to find out kinetic energy. Okay, so this is the one I given, that thorium 232, thorium 232, thorium 232. Okay, this one, alpha particle gets decay, alpha particle and becomes radium, right, 228 radium. Okay, so we have been given that Q value for this reaction, that is given, Q value is given. That is 40,4082 kilo electron. Okay, this is the Q value we have been given. So there is a formula, guys, and we need to find maximum possible kinetic energy. Okay, so there is a formula, that is Q alpha, or Q value, that Q alpha is given, that is Q value, okay? Q alpha, because alpha particle gets different. Q alpha is equal to, that is A upon A minus 4, A upon A minus 4 K alpha. Okay, there is a formula, guys, you need to note down. So Q value in this reaction, for any reaction, Q value is equal to A upon A minus 4 K alpha. K alpha is the kinetic energy, right? Q alpha is given, guys, so we can write it Q alpha. Q alpha is given, that is 4082, right? And A, that is atomic mass of thorium, right? That is 232, 232 upon A minus 4 means atomic mass minus 4, that is 230, this one 230, 232 upon 232 minus 4 into K alpha. K alpha is the kinetic and maximum kinetic energy, right? And that is this 232 minus 4 means 228 radium, right? So this is going to be 4082 equal to 232 upon 228. 232 minus 4 means 228, right? And this is K alpha. K alpha is the kinetic energy. Very simple. So kinetic energy, this is very simple question, formula based question, right? 4082 into 228 upon 232, right? We will solve it, and by solving we are going to get what would be the answer. So answer is going to be 4012 kilo electron volt. Okay, 4012 kilo electron volt, and this is the answer. Okay, 4012 kilo electron. Very simple. This formula you need to note down. Okay, Q alpha, that is Q value for alpha. Q alpha equal to A upon A minus 4 K alpha. Okay, alpha particle is decayed from this thorium, right? So this Q alpha is A upon A minus 4 K alpha, and from here we got the value of K alpha. Very simple question, and it's a 5 marks question. Okay, sir, GATE syllabus is same, but CSIR, okay, but CSIR net syllabus have advanced mathematics. Okay, sir, I think I have already answered it. GATE syllabus is same, but okay. So as of now, what I would like to suggest to you, elements, that focus on your this BTech syllabus, and try to get as a more percentage. Okay, try to get good percentage in your BTech exam. Meanwhile, give the exam of GATE and NET, right? If you qualify it, it's a good thing, right? Then you can easily get admission in PhD and MTech. But as of now, I would suggest you give more priority to your BTech exam in your BTech, right? Because getting good percentage in BTech is important. So these exams you can give after BTech as well, but the percentage is very important. So I would suggest you focus on your BTech exam. Meanwhile, give the exam of GATE and NET. If you qualify it, that would be great. After that, you have lots of opportunity, but don't compromise with your percentage. That's what I would like to suggest you. But give the exam of these two as well. Okay. Next is okay. Next question. Question number 4. Question number 4 is, it's a good question. Question is, in 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 the reaction, in the reaction, in the reaction, in the reaction, P plus N, P plus K plus X. Okay, this is the reaction which is given. This is the reaction which is given. Mediated by mediated by strong interaction. Mediated by strong interaction. Mediated by strong interaction. The baryon number, the baryon number, the baryon number B, baryon number B, baryon number B, strangeness S, strangeness S, and the third component of, and the third component of, third component of, third component of isospin, third component of isospin, that is I3, of the particle, of the, of the particle, of the particle XR respectively, option A is -1, -1 and -1. Option B is 1, -1, 1 -1 and -1. Option C is 1, -2 and -half. Okay, option D is -1, -1 and 0. Okay, so these are the options. Okay, so this is the question. In the reaction is given P plus N equal to P plus this P is proton, N is neutron, okay, and K plus is kaon. X is unknown element, okay, mediated by strong interaction, okay, mediated by strong interaction. The baryon number B, strangeness, this is the reaction we have been given, and baryon number B, strangeness S, and third component of isospin I3 of the particle XR respectively, you need to find out. Okay, very good question and very simple question. I have explained everything in detail in my nuclear physics lecture. So I have taken complete detailed course of nuclear physics in 2 lectures, and that is available in the playlist. Okay, so I would suggest you please watch those lectures, those 2 lectures, very important lecture, and after that you can easily solve questions related to nuclear physics. Okay, okay, so I'm going to solve it. Okay, so we have been given this reaction, guys. First reaction is given. Reaction is P plus N equal to P plus K plus and X. Okay, so this is the reaction we have been given. We need to find out baryon number, strangeness, and I3 component. Okay, so here that we know, guys, this one I have already made a chart in my nuclear physics lecture, so you can check that. Okay, and explained these elementary particles and their classification. So if you will go through my lectures, there are 2 lectures I have taken, and that is complete detailed course of long lectures and complete detailed course of nuclear physics. If you check that, you can easily solve all the questions related to nuclear physics. Okay, so here in this chart which I have explained, right, proton and neutron are baryon number, guys. Okay, these are baryon. It means these are baryon means these are classified as a baryon. So baryon means this is 1. This baryon number for proton is 1, for neutron is 1. For balancing this equation, okay, so this is baryon, right, 1. And cation is not baryon, guys. Okay, cation is not baryon, so it means it is going to be 0. And for balancing this equation, it means this unknown element, the baryon number for this unknown element is 1, means it is baryon. Okay, so this X is baryon. So baryon number we have got it. Now we'll get strangeness. We know proton, neutron, these are not strange particle. Okay, so it means strangeness for proton and neutron is 0. Okay, so it means this is 0. Okay, this is 0 means and if we talk about this cation, the strangeness for this cation is 1, guys. Okay, so it means for balancing this equation, the strangeness is going to be -1. How we have got it? The strangeness of cation is a formula, guys. Okay, so by this formula, this is Q equal to I3. Okay, I'll tell you later. Just leave it out. Now we are going to find I component, I3. I3. I3 component for proton, we know that I3 component for proton is half and for neutron is -half. Because we know I component 2I plus 1 equal to 2, because there are two particles. Okay, that proton and nucleon. For nucleon, there are 2 nucleons, right? Proton and nucleon. This I have explained in my lecture, so I would suggest you please watch these 2 lectures. That is complete detailed course of nuclear physics. So from here, I is going to be this 1 by 2, and if I is 1 by 2 for proton, then for neutron it is going to be -1 by 2. Because if we know the I, then I3 is going to be minus I2 plus I, right? So now if we talk about this one, this proton, this is going to be half, and for cation also it is half, guys, because there are two elements for cation, K plus and K0. Okay, so again 2I plus 1 is going to be 2. There are two particles, right? So from here, so for this, for understanding these in detail, I would suggest you please watch my lecture. Okay, detailed course of lecture. This is, I have completed nuclear and nuclear and this particle. I have completed particle physics in 2 lectures. You can watch that. So from here, this is going to be 1 by 2. Okay, so for balancing it, balancing this equation, right? This is going to be minus 1, because 1 by 2, 1 by 2. This is 1 by 2 minus 1 by 2, 0. So this is 1 and minus 1. So this is 1. So value of B is 1, value of S is minus 1, and value of I3 is minus 1. So which option is matching, guys? Option B is matching. Okay, option B, this one. 1 minus 1 and minus 1. Okay, so this is how we get the baryon number, strangeness, and I3. And there is a formula for getting strangeness as well, guys. This is Q equal to I3 plus S plus B by 2. P is baryon number, S is the strangeness, and the I3 component, and Q is the charge. So for example, if you want to find out this for cation, the strangeness, so how we are going to get is, for cation the charge is K plus, right? For K plus, that is charge is 1. I3 component for this is 1 by 2. I have explained this 1 by 2, right? 1 by 2 plus strangeness we don't know, and cation is not baryon, means value is 0 by 2. Okay, so this is going to be S by 2 equal to half. Half will go there. 1 minus half means half. 1 will get cancelled. That value of S is going to be 1. Value of S is going to be 1. Right? This is how we get the strangeness. I hope, guys, you have understood it. Okay, next question. Next question is, this is also a good question. Question is, in an elastic scattering, in an elastic scattering, in an elastic scattering, in an elastic scattering process, in an elastic scattering process at an energy E, the phase shifts satisfy delta naught almost equal to 30 degree, comma delta 1 almost equal to 10 degree. Okay, while the other phase shifts, the other phase shift, other phase shifts are 0. Okay, the polar angle, the polar angle, the polar angle at which, the polar angle at which the differential cross section, the differential the differential cross section, the differential cross section peaks, differential cross section peaks. Okay, we need to find out the polar angle at which the differential cross section peaks, means the value of differential cross section is maximum, right? Is closest to, is closest to, is closest to number A, number A 20 degree, number B 10 degree, number C 0 degree, and number D 30 degree. Okay, so this is the question. A very good question. Okay, so I'm going to solve it. Okay, so let me explain the question first. So in an elastic scattering, so we are talking about the scattering which is elastic, okay, which is elastic, there is no energy loss. So in an elastic scattering process at energy E, okay, at energy E, the phase shifts satisfy delta 0 value is almost 30 degree, delta 1 value is almost 10 degree, while other phase shifts are 0, okay. Polar angle at which the differential cross section peaks. Okay, so we need to find that polar angle at which the differential cross section value is maximum, is closest to this. Okay, simple question, formula based question. So I'm going to solve it. Okay, so okay, in the partial wave expansion, 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 the differential scattering, the differential uh, scattering, the differential scattering cross section is given by, in partial wave expansion, okay, the differential scattering cross section is given by, so there is a formula given, is given by, that is d omega upon d, sorry, d theta upon d omega, d theta upon d cos theta, or d omega we can say, that is given, that is this is, this formula is, or we can write d theta upon d omega, right? So this is mod of, this is very important formula, guys. I'm going to write in red. Okay, so this is mod of sigma L 2L plus 1 e to the power delta L iota delta L sine delta L, sine delta L PL cos theta mod square. Okay, so this is very important formula. You need to note down. So this is the formula, guys. Okay, so from here d theta upon d cos theta, this is differential cross section. This is going to be, so we need to find out the angle at which this differential cross section is maximum, right? So at so this, from here, this d upon d cos theta is going to be equal to 0, right, for maximum value. Maximum. Okay, for maximum value, this value is going to be 0, means this value is going to be 0. So this means mod square of this value is 0, means this square will go this side. So this is going to be, it means sigma L 12 plus 1 e to the power iota delta L sine delta L PL cos theta, okay, equal to 0. This is mod square because that is equal to 0, so that's why this value is going to be equal to 0. Very simple thing. So we'll take L equal to 0 first. So this is going to be this one. It's a very good question, guys. Okay. This is mod. Okay, mod is going to be 0. Square we can take this side, so mod is going to be 0. So this means this is going to be this one. For 0, this value is going to be this. 0 means 1, right? So 1 into e to the power iota delta 0 for L equal to 0, okay, sine delta 0, and this is P0 cos theta, this is legendary polynomial, right, plus 3, L equal to 1, 3 into e to the power iota delta 1 sine delta 1 P1 cos theta, right. This is going to be equal to 0. So from here cos theta is going to be this one, minus e to the power iota delta theta, this is sin theta upon cos theta. This PL cos theta, this value, this legendary polymer, P0 cos theta value is 1 and P1 cos theta value is cos theta, guys. Okay, so this upon 3 sin delta 1, 3 sin delta 1 and cos delta 1, 3 sin delta 1 cos delta 1. Okay, so this is the value. We can simplify it further, so it is going to be cos theta equal to minus 1 upon 3, and I can multiply by 2 and divide by 2, right. So this is going to be 2, this one first, yeah, this one, right. So I will open this e to the power iota delta naught, e to the power iota delta naught delta 1 delta 0, this is going to be sin theta, sorry, cos theta, cos delta 0 plus iota sin delta 0, right, and we are ignoring this imaginary term, right. So then it is going to be cos theta value is going to be 2 cos delta 0 sin delta 0, okay, this is sin delta 0, okay, delta 0, because I have ignored this, because we know e to the power I theta equal to cos theta sin theta iota sin theta, right, cos theta iota sin theta. So imaginary part I'm ignoring, because we need to find the theta value, right. So this is again, this is going to be 2, this one, if I open it, that this is e to the power iota delta 1, and this is cos theta, because this legendary polynomial formula, right, we know P0 x value is 1, and this P1 x value is x, right? In this way, this P0 cos theta value is 1 and P1 cos theta value is cos theta. Okay, so this is going to be 2. Again, I will open it, this e to the power iota delta 1, right? And I will ignore this, neglect this imaginary part, or I will ignore that, right? I'll leave that part. So this is, I'll take only real part. So this is going to be 2 cos delta 1 . This is 1, right? Just wait. This is going to be 2 cos delta 1 and sin delta 1. Sin delta 1. This is sin delta 1, guys. Sin delta 1. Right? So 2 cos delta 1 sin delta 1. Cos theta is here. Right? So I have multiplied by 2, divided by 2. So cos theta value is going to be minus 1 by 3. 2 sin a cos theta, sin theta cos theta, 2 sin theta cos theta means sin 2 theta means 2 delta naught upon sin 2 delta 1. Cos theta value is going to be minus, and this 1 by 3, and sin delta naught value is given, that is 30, right? So means sin 60. Sin 60 means root 3 by 2 upon this one, or I can write like this simply, minus 1 by 3 sin 2 into delta 0 is 30, right? Delta naught is 30 means sin 60 upon sin delta 1 is 10, so sin 20. Okay, so cos theta value, this value is going to be, I put the value, so this value is going to be minus 0.844. Okay, this is the value. So from here, cos theta, I am taking that mod value, so cos theta value is going to be, I'll take positive value, right? Cos theta value is going to be 0.844. I'll take mod value, right? So this is going to be point or 0.844 cos theta. So from here, theta value is going to be cos inverse 0.44. Okay, so this value is going to be, theta value is going to be 32 point 32.4 degree. Okay, 32.4 degree. Okay, so this is the answer. So which option is matching, guys? Let me check. So closest value is D, 30 degree, right? So option D is the correct option, guys. I hope, guys, you have understood it. So option D is the correct option. It's a good question. Okay, guys. So now I'm going to stop here, and also, guys, I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, and also, guys, please share my lecture details with your friends so that they will also be able to watch my free lectures and will be benefited from it. Okay, guys, thank you so much. Bye now.